Everyone, in this video we're going to go through the final two questions, so question 5 and 6. So let's scoot down to question 5. Alrighty, so let's make it a bit bigger. So Frankie wins the lottery and decides to invest his winnings into an annuity that earns interest at a rate of 5.2% per annum, compounding monthly. All right, let's just highlight a few things as we go along. So here is our interest rate. It is an investment, so it's important to note whether it's an investment or a loan, and it's compounding monthly. All right, and he will receive from this annuity $4,500 per month. After 2 years, Frankie has this amount in the annuity. All right, and we have to calculate the original investment. So after 2 years, all right, I should have highlighted that. Okay, so it's 24. So 2 times 12 gives you the 24. We've got our interest rate. The principal value is what we're looking for, or your present value. Payment. Now, you've got to make sure you're getting your negatives and your positives correct. So the payment is coming back to Frankie. So that's why it's positive 4,500. The future value is also Frankie, so it's also positive. And the payments per year and compounding periods per year is 12. All right, and then just plug that into your calculator and we get that number. So just making sure you also round. So we do get this number here, and then it rounds to 975,000. Wouldn't that be nice to win in the lottery? All right, 3 years after the initially investing the money in an annuity, Frankie decides he will convert the annuity into a perpetuity, earning the same interest rate. So remember, the main difference between an annuity and a perpetuity is an annuity will eventually go down to zero, whereas a perpetuity is a type of annuity, but it differs in that it will never go down. So if he invests, say, $1 million, he'll only be living off the interest of that $1 million. It will never go down to zero in a perpetuity. He would like to continue receiving a payment of $5,000 per month. So he's going to get $5,000, so it's increasing. He's advised that he would need to make an additional one-off payment to the perpetuity to receive that payment. So we know before he was getting less than that, and it was an annuity. So in order to get $5,000 per month, he needs to add a little bit more to ensure that it stays as a perpetuity. All right, so we've got to calculate what that one-off payment is. So we're doing this after 3 years, so that's why we've got the 3 times 12. The interest rate is the same. We worked out the principal value before was 975,000. It is negative because that's actually money going into the bank, into the annuity. Payment is positive 4,500, and the future value is what we're looking for, which is this amount here. Now, if we want to know what the principal value is, we know that we're going to get $5,000 in payment. So we're just going to do 5.25%. We're going to be dividing it by 12 because this is a monthly rate. So 5.25 divided by 100 times 12 times your principal value has to equal 5,000. It's a bit hard to do that on the financial solver because your PV and your FE have to be the same. All right, so your principal value is this amount. All right, so that's how much he would have to start off with to get the $5,000. So we just got to work out the required one-off payment. So this is how much he has to start with. After 3 years, he had that amount. So he has to add in $176,973.86 after 3 years into that annuity to turn it into a perpetuity to get the $5,000 per month. Alrighty, moving on to question 6. So Frankie speaks to his friend Sophie, who has a mortgage. Sophie shows Frankie her new amortization table with some of the details of her loan. However, Sophie cannot remember any details about her loan. Using the excerpt from Sophie's amortization table, list what information, including any figures, you can find out about Sophie's loan. Round any values to 2 decimal places. So we can see that the payment starts at 30. So we can start thinking about, well, hasn't given us the initial value or the initial loan amount. It hasn't told us anything about the interest rate. It hasn't told us how long it's going to take the loan to be paid off. It hasn't told us how much interest has to be paid. It hasn't told us what the compounding periods are per year. So there's a lot of information that we can actually get. So this question was quite open-ended, testing your knowledge of amortization tables. All right, so the first thing that you probably did was calculate the compounding period interest rate. So we just take the interest and divide it by a previous amount, which you can see I've done here, and we get this number. Now it's important not to round that number, because if we're calculating the monthly interest rate, it's actually going to round to, if we're doing it to 2 decimal places, to 6.01. So here it says round to 2 decimal places. So if you did round it to 6 decimal places, you're actually not going to get these amounts. Okay, so you've got to make sure that you're, you round that value. So if you did get that 0.5 per period, that's great. You're probably awarded a mark. So either that or the annual interest rate, depending on what compounding period it was. So you can see this is done for monthly. You could also do it for any other compounding period. So you could have done fortnightly, weekly, whatever, as long as your calculations were correct. So this one is done for monthly. Most people did monthly, so we're going to stick with that. So we've got our payments there. That was a bit of a gimme mark. All right, so payments are $3,901.26 per compounding period. You can see my working out here was just working out the principal value. So it didn't matter what compounding period you chose, you should have got that $650,000 no matter what. And you would have got the same loan length. So the 650,000 and the 360, you could have had 360 quarters, 360 weeks, whatever. All right, so here we've got it in months. So that translates to 30 years. If you left it in months, that is also fine. Working out your final payment. So I've done that down here. All right, so our final payment, you can work out the 359th payment and do your final payment that way. I just find it a lot easier to do it this way. So after our 360th payment, we were left with an overpayment of $1.64. So we just take that away from our final payment. So our final payment is this amount here. So a little bit more of a higher level thinking part there, getting that final payment. And then also you could have done the total interest. So also a bit more of a higher level thing to find. So we've got 360 payments of that amount. So the $3,901.26. But remember, we overpaid by $1.64. So taking that into account and then taking off your initial borrowing amount, and we're left with that. So, looking at different features of that amortization table to get full marks for this question. But, if you got some of these, you would have got partial marks. All right, guys. Bye.